This video is going to look at how we can calculate the height of a rectangle in between two different functions. And this is going to be a particular problem that you're going to deal with more when you get into calculus, but I just want to kind of introduce this here in pre-calc for you. Now, here we have two graphs. We have y equals 4x minus x squared, and that's a parabola here that's opening down. And then we have y equals 2x, which is the straight line here going at an angle upwards. And we want to calculate if there's a rectangle here, we want to find the height h of this rectangle. Now, I'm not saying that I want to find the height of this specific rectangle. I want to know what would be a way that we could come up with a function to represent the height of any rectangle, no matter where I draw it here, in between these two particular graphs. How could we come up with a function to represent that particular height? Now, before we look at this problem, maybe I'll present you with another example over here. Let's say that here we have the equation of a line y equals 6, and then we have another line here, and we'll say this is y equals 2. And if I want to find the height of this particular rectangle here between these two functions, so between the two graphs here, what is the height of this rectangle? And again, no matter where I draw the rectangle, I want to know what is the height in between these two particular graphs. Well, you would probably think intuitively, you would take your top function here, which is 6, and the bottom function is 2, so you would take the top, which is 6 minus 2, and I'm sure you would probably come up with and say, well, the height is going to be 4. And that is correct. No matter where we draw our rectangle here, the height of this rectangle is always going to be 4 because we have two horizontal lines. And the height of any rectangle here is going to have a height of 6 minus 2, which is 4. So we want to apply the same concept over here with the y equals 4x minus x squared and y equals 2x. Well, which of the function is on top? Well, the parabola, if we look here, this part, this function, the 4x minus x squared, is the function that is on top. So that's kind of like our y equals 6 over here. The function that's on the bottom, like our y equals 2, is going to be y equals 2x, which is the straight line. So what we want to do is, we want to do the same thing we did over here. We want to calculate the height by taking the top function, just like we did with the 6, but our top function over here is 4x minus x squared. So we have 4x minus x squared. And we're going to subtract away the bottom function, which is the 2x. So then if we solve for this, then we have h is equal to 4x minus x squared minus 2x. So then the height of this rectangle would be 4x minus 2x. So 4x minus 2x is 2x minus x squared. And we could rewrite this, it doesn't matter, either one of these. You could put the x squared first if you want to put your exponents in descending order, so you'd have a negative x squared plus 2x. So here we have the height of our rectangle. So for example, if I want to know the height of the rectangle at, let's say, here at 0, then at h of 0, we would end up with our 0 squared plus 2 times 0. So at 0, the height is 0. And that's because here we don't have the lines are intersecting, so there is no height. There is no rectangle. If I want to know what is the height of the rectangle, let's say located over here at x equals 1, then that means I would draw this rectangle here, and I want to know the height. So that would be h of 1. Plug 1 in for x, we'd have minus 1 squared plus 2 times 1. And we would end up with 1 squared is 1, so we have minus 1 plus 2. So 2 plus a negative 1 here is simply 1. So x equals 1, then the height here of our rectangle is also 1. And you could do that throughout any point here to calculate the height of the rectangle. Now, if we were able to do that with a whole bunch of rectangles, and this is kind of, again, kind of a foreshadowing of what you would do in a calculus class. I'm not going to hold you to this for this class. But if you imagine drawing a whole bunch of rectangles in here, we can calculate the area of each rectangle. Because we know the area of a rectangle is length times width. And if we find the area of each rectangle, we could add that up. And that would give us the area that is in between these two curves. And the area between these two curves, notice we don't have a formula to find the area between the two curves because it's not a geometric shape that we have an area formula for. So it may be that we want to find the area of this region, and using calculus, we can basically sum up the area of all these little rectangles in here to find the area of this particular region. Now for us, I just want you to be able to possibly identify the height of this rectangle. And again, if we're trying to find the height of this rectangle, you're going to take the equation, the top function, minus the bottom function. Okay, so just like we did over here on the right, it's the top function minus the bottom. So just make sure you're careful when you're subtracting. You distribute the negative when needed. So the top function minus the bottom is going to give you a representation for the height of your rectangle.